Hello everybody, it's a very good day. We are going to discuss concepts on waves, ray optics and optical instruments along with wave optics. See, the concepts are first waves. In this types of waves, wave velocity, superimposition of waves, strings, argon pipes, Doppler's effect. After that, optics. First waves. Wave is a disturbance in a medium. Mechanical wave needs medium. And examples for mechanical waves are sound waves. Let me take up a pointer. Yeah. Sound waves and light waves are what you call three-dimensional. Two-dimensional ripples on a liquid surface. One-dimensional waves are along a string. And you know mechanical waves needs medium. And then non-mechanical waves, electromagnetic waves and all, does not require any medium, light waves, radio waves, etc. And progressive wave, the wave proceeding in the medium with velocity and never return to the original position is a progressive wave, and that's characteristics, actually wave characteristics, that need not be only progressive. Frequency, number of waves produced per second. Time period, reciprocal of frequency. Angular frequency omega 2 pi n or 2 pi by t. Time period is reciprocal of frequency or 2 pi by omega. Wave function f of x plus or minus vt. There should be a function with f of x plus or minus vt. If plus vt is there, it is propagating along negative x-axis. If minus vt, then it is propagating along positive x-axis, or for x, whatever. Other forms of a wave function, y is equal to x minus vt whole square, y is equal to square root of x minus vt, y equal to ae to the power of some constant into x minus v whole square. All these are all wave functions only, wave forms only. We know usually sinusoidal wave, that's it. We introduced in such a way, but many wave types are there. Sawtooth wave, square wave, many waves are there. Differential form of a wave equation is nothing but SHM type of equation. D square y by dx square equal to 1 by v square d square y by dt square. Propagation constant k equal to 2 pi by lambda. Wave velocity is v equal to omega by k, that is equal to n lambda. Omega is quotient of time and k is quotient of x. And velocity, group velocity, that is equal to vz, that is equal to d omega by dk. And progressive wave equation, y is equal to a sin omega t plus or minus kx plus or minus phi. This is a progressive wave equation. Other forms just we have discussed. And y is equal to a by b plus x plus or minus vt whole square also forms a wave equation. And the relation between the phase difference and the path difference, 2 pi by lambda into x is the phase difference. Delta phi is equal to 2 pi by lambda into delta x. And velocity of the particle, whatever the oscillating to propagate the wave, that is undergoing SHM. That's maximum velocity is a omega. And particle acceleration, wave velocity, wave accelerations are different. Particle of the medium, velocity and accelerations are different. A omega square sin omega t minus kx is particle acceleration, and its maximum acceleration is omega square a, or a omega square. And relation between particle velocity and wave velocity is particle velocity is equal to wave velocity into minus dy by dx, which we will call slope of the wave, slope form of the wave function. And kinetic energy by volume is nothing but energy density, which is equal to potential energy by volume. Both will be maintained equal quantities, and that is equal to half rho a square omega square cos square omega t minus kx. The average energy associated with volume is equal to half rho a square omega square into volume, and that is equal to some s into delta x. Power, P is equal to half rho a square omega square SV. And intensity equal to half rho a square omega square into V. Intensity means energy per unit area in unit time. That can be modified into this format. Velocity of the wave V is equal to n lambda, and velocity of transverse wave V is equal to root t by mu. General wave velocity is V equal to n lambda, but on strings wave velocity is V equal to root t by mu, where t stands for tension, mu stands for linear mass density, and mu stands for linear mass density. A is area of cross section, then that same format can be changed into V is equal to root T by A rho. Root T by A rho, rho is the density. And string is stretched by a tension mg, suspended weight, then root over mg by mu. And that suspended weight is immersed in a liquid, then mg of 1 plus sigma by rho will be the new tension. So new tension by mu will be so-called wave velocity. And tension is equal to, tension is changed or final tension is because of thermal stress. Then Ya alpha delta T is the thermal stress caused tension, then wave velocity will be taking that place. And wave velocity V equal to root YAE by mu L. Time taken by the wave to move from bottom to the top for a suspended string is T equal to 2 root L by G, not 2 pi root L by G. It is true only, it is correct only, not a printing mistake. 2 root L by G only. Velocity of sound in solids is equal to square root of, this is velocity of sound in solids, root over Y by rho, Young's modulus by density, and root over bulk modulus by density for liquids. For gases also, Newton assumed the same format, but it is proved wrong. So Newton Laplace corrected the formula. So that is gamma P by rho, square root of gamma P by rho, square root of gamma RT by M. This is the velocity of sound in gases. If the displacement of the wave y1 is equal to a1 sin omega t, y2 equal to a2 sin omega t plus or minus 5, then resultant amplitude is a equal to square root of a1 square plus a2 square plus 2a1 a2 cos phi. Intensity is proportional to a square, amplitude square. Intensity always proportional to amplitude square. I1 by I2 equal to a1 square by a2 square. I maximum by I minimum when they superimposed, that is a1 plus a2 by a1 minus a2 whole square, or root I1 plus root I2 by root I1 minus root I2 whole square is intensity's ratio. Next, y1 is equal to a sin kx minus omega t, y2 is plus omega t, that means one is going in one direction, other one is in opposite direction. Then stationary wave equation y equal to 2a sin kx cos omega t, amplitude of the wave equal to 2a sin kx. And next, when a string is fixed in both ends and n is equal to frequency produced by the string, p by 2l root t by mu, p by 2l root t by mu, root t by mu is velocity only, p by 2l will give you wavelength. So n is equal to v by lambda, it is actually. So v by lambda, 2l by p will be the wavelength. P is number of loops and t is tension, mu is linear mass density. Fixed at one end, free at the other end, then number of loops formed is p, then frequency is given by 2p minus 1 by 4l root over t by mu. This is also possible actually. And in this case, only odd harmonics are available. In that case, all harmonics are available. Harmonics means integral multiples of fundamental frequency. Next, n is proportional to 1 by L, n1 L1 equal to n2 L2. Everything, these things will come with n equal to 1 by 2L root t by mu formula. Next, these are all pipes. Fundamental frequency of first harmonic of an open pipe is V by 2L. Next one 2V by 2L. Next one 3V by 2L. So here L is missing. I will write L is missing 2L. So ratio of them is 1 is to 2 is to 3. All harmonics are produced in this. All harmonics are produced. Closed pipe. Fundamental frequency V by 4L. And next frequency 3V by 4L. Next frequency 5V by 4L. So 1 is to 3 is to 5 is to so on. Only odd multiples are possible. 2p minus 1 into v by 4l. P starts from 1 onwards, right? So ratio of frequencies odd multiples. Only odd harmonics are produced. And with end correction, n naught is equal to, for open pipe, n naught means open pipe, v by 2 into l plus 2e, where e is equal to end correction 0.6 r or 0.3 d diameter. And closed pipe, n is equal to v by 4 into l plus e. E is same value 0.6 r or 0.3 d. This is for closed pipe end correction. Next, resonance and resonating air column experiment. Same tuning fork is used for first resonance and next immediate resonance. The gap will be lambda by 2 because one extra loop will come. So that is End correction can be L2 minus 3L1 by 2, and velocity of the sound in the particular medium is equal to n of L2 minus L1. L1, L2 are successive resonances. Next, beats. Beat time period is 1 by n1 minus n2. Beat frequency is n1 minus n2. Always frequency time period are reciprocal only. A tuning fork of frequency n is taken, and then when wax is added, its frequency decreases. On filing, its frequency increases. With this, beat sums can be done. Doppler's effect. Whenever there is a relative motion between source and observer, there will be an apparent change in frequency and wavelength, which causes the audibility change. It is strictly apparent. So this is Doppler effect. And finally, one formula you can have in your mind, that is both are approaching each other. When both are approaching each other, this formula will come: V plus V naught by V minus Vs into n, when both are approaching each other. You can learn only this equation. With this, if observer is at rest, put V naught 0. If source is at rest, put Vs 0. So whoever is at rest, put them 0. And this formula is whenever both are approaching each other. If one person is going away, then put minus for them. So easy. Why to learn all those formulae? Only one formula is enough. N dash is equal to V plus V naught by V minus Vs into n. This is V only. V stands for velocity of sound. V naught stands for velocity of observer. V stands for velocity of sound. Vs stands for velocity of source. N is natural frequency, original frequency of the source. N dash is apparent frequency received by the observer. All the cases will come with that. Source of sound is crossing a stationary observer, then difference in apparent frequency is given by 2nVs by V. 2nVs by V. N is the original frequency, Vs is the source frequency, source velocity, V is velocity of sound. And the same is applicable for even light also, but for that, or electromagnetic wave, you have to take velocity of electromagnetic wave 3 into 10 power 8. Remaining things as usual, right? Next, Doppler effect in case of reflection of sound. Suppose sound is reflected from the wall and a tuning fork is in between the wall and the observer, then he is going to receive Doppler effect thing. See, that is maybe in the second case. Yes, the source must be between reflector and the observer, then only you are going to receive Doppler effect. If the source is behind the observer and the wall, then there is no Doppler effect. This must be kept in mind, because whenever source is moving towards the wall should get increased frequency, person should get decreased frequency, then only you are going to have a Doppler effect. And for this also, change in frequency is 2nVs by V. Next, Doppler's effect in case of revolving things. Then whenever a source is revolving, then its maximum velocity will be r omega, minimum velocity will be also r omega. In that case, the frequency will be frequency received. Here observer is at rest, so n into V by V minus r omega. Here it is Vs actually, not V5. Vs stands for velocity of source. Velocity of source. Here V5, not V5, that is V5 is nothing but Vs here. Velocity of source is equal to r omega, you can take. So this is V minus r omega while approaching and V plus r omega while leaving. So whenever the speaker is coming towards us, V minus r omega, speaker is going out, V plus r omega, you have to take. This can be, this is a similar situation when a girl is blowing a trumpet and swinging on the, what you call as cradle, in that case also. When velocity of sound is considered, effective velocity is equal to V plus V of the source into cos theta. Or what is this, wind flowing, then VW or cos theta, wind component you can take. Wind also helps or dishelp. Next, Doppler's effect in light. Doppler's effect is applicable for light also, but instead of sound velocity, you have to take light velocity, that's it. Lambda dash is equal to lambda into 1 minus u by c. Lambda dash is equal to lambda into 1 plus u by c. When the source is going away, then wavelength increases. When source is coming closer, then wavelength decreases. Wavelength decrease causes blue shift, wavelength increase causes red shift. Red means higher wavelength, okay, blue means lower wavelength. And now we will go for ray optics. We'll discuss this topic now. This lesson contains reflection of light by spherical mirrors, refraction. Plane mirrors we have discussed in 8th class, 9th class, right? That's why. Total internal reflection, refraction through a prism, optical instruments, telescope, microscope, and simple microscope, those things. Next, laws of reflection. These are all laws of reflection is same for plane mirror or curved mirror. Laws of reflection will be same, not only for light, any wave types. Incident ray, the reflected ray and normal at the point of incidence lie on the same plane. Incident ray, the reflected ray and the normal at the point of incidence lie on the same plane. Angle I is equal to angle R. Characteristics of image due to reflection by the plane mirror is the size of the image is the same as that of the object, and the real object for a real object the image is virtual, and for a virtual object the image is real. What is that in reflection? In order to see full image of a person, the minimum size of the mirror, it's a plane mirror, should be 1/2 of the person's height, and he has to stand at the middle of the room. And for a fixed incident ray, if the mirror is rotated through an angle theta, then reflected ray turns through an angle 2 theta. In the same sense, deviation produced by the plane mirror is equal to pi minus 2i. Deviation means this one. This is deviation, delta. Delta is deviation. Next, deviation produced by two mirrors inclined at an angle theta is 360 minus 2 theta. And images formed by two mirrors in contact, suppose theta is the angle between them and object is different positions will be there. Object on angle bisector, not on angle bisector. That we will call it as object symmetric to the two mirrors or asymmetric to the two mirrors. See, 360 by theta is even integer, then number of images for all the positions is 360 by theta minus 1. It should be odd. Next, if 360 by theta is an odd integer, then cases will come. Next, if 360 by theta is a fraction, then number of images formed will be equal to the integral part. That means if it is suppose 7.3, you shouldn't go for 8, you have to go for 7. You shouldn't go for 8, you have to go for the previous integer. Okay. Next, object moving along the normal to the plane mirror which is at rest. Object moving along the normal to the plane mirror which is at rest. Then velocity of object with respect to image is VOL is equal to, that means velocity of object, this is not L, this is I, you can feel, that will be better. Velocity of object with respect to image is equal to velocity of object minus velocity of image, that is 2 times of velocity of the image and or object, whatever. Note Vi plus V naught by 2 is equal to Vm, and object moving parallel to the plane mirror at rest. Then object moving parallel to the plane mirror at rest actually here, then image velocity also will be same with respect to the mirror, and our image velocity with respect to object is 0 because it comes along with it. Those things we are going to write here. Yeah. So velocity of object with respect to image 0. Velocity of object with respect to velocity of image with respect to mirror is same velocity. Spherical mirrors formula is 1 by f is equal to 1 by v plus 1 by u. Minus is for lens, mirror will have plus, and r is equal to 2f. Size of image by size of object will give you magnification, linear magnification. Transverse and lateral magnification is lateral magnification is hi by h naught equal to minus v by u for mirrors. Same side, no, that's why minus sign will be there. Longitudinal magnification is length of image by length of object, that is along the principal axis, minus v2 minus v1 by u2 minus u1. And for a small object, magnification longitudinal is equal to minus dv by du equal to v by u whole square, that is equal to m2 square. And superficial magnification or aerial magnification. Aerial magnification, when an object is placed perpendicular to the principal axis, A image is equal to m square A object. Area of image, area of object they are. When an object is placed along the principal axis, then aerial magnification is m cube into area of the object. Next, volume magnification is m power 4 into volume of the object. Graphs for concave mirror. Concave mirror graphs will be 1 by u, 1 by v will be straight line, and 1 by u, 1 by v for virtual image will come like this, for real image will come like that. And UV graphs will be like this. UV graphs will be like this. UV, so the 45 degrees angle will cut at 2C, 2F, 2F. Next, this is U and M. Next, all graphs on one place. Nice, right? Yes. These graphs you need to practice. Power of the mirror negative minus 1 by f in meters or minus 100 by f in centimeter. Diopter is the unit of power. Refraction. Incident angle and refracted angle, everything must be measured with the normal. Angle of incidence in one medium, angle of refraction in the other medium. Snell's law, mu1 by mu2 is equal to sin 1 by sin 2. Actually, it is mu sin theta equal to constant. Mu sin theta equal to constant. I think I told reverse, I pronounced reverse. I felt in my mind like this. Mu1 sin theta 1 is equal to mu2 sin theta 2. So, mu1 by mu2 is equal to sin theta 2 by sin theta 1. This you have to kept in your mind for refraction. Next, vector form of Snell's law, mu1 of E cap into N cap, mu2 of E2 cap into N cap. Directly this step asked in a competitive examination. Which of the following is Snell's law? He asked vector form. Just vector, unit vectors, cross product is sign will come, right? That's why. Absolute refractive index is velocity of the light in free space by velocity of light in a medium. Then we'll have absolute refractive index, that is equal to relative permeability, relative permittivity product under root. This absolute refractive index, and relative refractive index will be different. Relative refractive index is mu2 by mu1, that is velocity of light in first medium by velocity of light into which it is entering, that is v2, and lambda 1 by lambda 2, d1 by d2, t2 by t1, and optical path difference. Optical path difference is the path traveled by the light in free space in equivalent time, that is optical path difference. And delta x is equal to mu minus 1 into d, and apparent depth is equal to, whenever an object is in another medium and observed from different medium, then optical apparent depth will come to act. Mu is equal to real depth by apparent depth, mu equal to real depth by apparent depth, and apparent shift is equal to S is equal to x minus SA, that is equal to x of 1 minus 1 by mu. These are all when object is in denser medium and viewed from the rarer medium. These two formulae, object is in denser medium, viewed from rarer medium. If it is reverse, then you have to inverse all the things. Then apparent depth due to a composite slab, multiple slabs, right? Then you can add x1 by mu1, x2 by mu2 like that. Object is in rarer medium, viewed from denser medium. Everything will be reverse. Mu is equal to apparent height by real height, HA by H, HA equal to mu H. Sun, even after set, it appears. The reason is this one only, because sun is in rarer medium, we are watching from the denser medium. In that case only this is. And normal shift is equal to 1 minus 1 by mu into t. Lateral shift is equal to t into sin I minus r by cos r for a glass slab. Next, t into sin I of 1 minus cos I by square root of mu square minus sin square I for lateral shift formula only this is. Expression for critical angle is equal to mu equal to 1 by sin c, and condition for total internal reflection is angle of incidence must be greater than critical angle and ray must pass from denser medium to rarer medium. So two conditions will be there. Field of vision of a fish. Fish cannot see whole world, it can see within a cone of experience. That is given by vertex angle of 2C to critical angle, and tan theta is equal to tan C is equal to h by r. Actually this is tan C equal to h by square root of mu square minus 1. Tan C is equal to r by h, right? Yeah, so r is equal to h by square root of mu square minus 1, and area of the aperture is equal to pi r square. R can be replaced here, and fractional energy transmitted is 1 minus cos theta by 2. Solid angle is 2 pi of 1 minus cos theta. Refraction at a spherical surface, Gaussian relation for single spherical refracting surfaces, that is mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. This is refraction at spherical surfaces. This formula is designed by Mr. Gauss. This Gauss, not only in electricity, he is a very dangerous fellow. He worked in many fields. Helped mankind. Yeah, they are good people. Principal foci. First principal focal length is f1 equal to minus mu1 r by mu2 minus mu1 for a curved surface. Second principal focus is equal to ft equal to mu2 r by mu2 minus 1. This is positive one, that is negative one, and like this. Magnification. Lateral magnification is equal to h by h naught equal to mu1 by mu2 into v by u for curved surfaces. And from Snell's law, mu1 I equal to mu2 r. Of course, we know longitudinal magnification is given by h by h naught equal to mu1 by mu2 into v by u. And same point only, that is, yes, longitudinal magnification is mu1 by mu2 into v square by u square, because longitudinal magnification, that is transverse magnification square into mu2 by mu1. Yes. Next, along the principal axis, if object is there, then velocity of image is vi is equal to mu1 by mu2 into v by u whole square into v naught. Velocity of image equal to ml into v naught, and perpendicular to the principal axis, velocity of image is equal to mu1 by mu2 into v by u into v naught. Par is equal to mu1 by f1, which is minus mu2 by f2, or mu2 minus mu1 by r. Length. Thin lens formula, 1 by f equal to 1 by v minus 1 by u. Newton's formula, f is equal to square root of x1 into x2. x1 and x2s are the distances for what you call distances from the lens. Lens maker's formula for thin lens, 1 by x is equal to mu lens by mu medium minus 1 into 1 by r1 minus 1 by r2. This is general formula, but this formula takes different forms. If it is a convergent lens, positive values, divergent lens, negative values. And lens immersed in a liquid, focal length in a liquid by focal length in air is equal to mu lens minus 1 by mu lens by mu liquid minus 1. Lateral magnification is equal to hi by h naught equal to v by u. Lateral means transverse, that means vertical, that is transverse. And longitudinal magnification, horizontal. Suppose a pen is along the principal axis, then longitudinal magnification is equal to, longitudinal magnification is ml is equal to v square by u square, that is mt square. Velocity of image is equal to v by u whole square into velocity of object, and vb mu b by v minus mu a by u is equal to mu minus mu a by r1 plus mu b minus mu by r2 if different medias are on either sides of the lens. And power of the lens is 1 by f in meters, 100 by f in centimeters. And two lenses are produced in contact. If two lenses are placed in contact, then powers can be added. P equal to P1 plus P2, or 1 by f is equal to 1 by f1 plus 1 by f2. If they are at certain distance, then you are going to have P1 plus P2 minus dP1 P2 when they are separated by certain distance. P1 plus P2 minus dP1 P2. Next, cutting of a lens. If the lens is cut in the first way, par will be halved, focal length will be doubled. If the lens is cut in the second way, par will be remains the same, focal length automatically remains same. One is along the principal axis, one is perpendicular to the principal axis. First one is perpendicular to the principal axis. Yes. Next, they are all normal things. Silvering of a lens. whenever a lens is silvered, then you have to feel that first ray enters into convex lens, next concave mirror, next convex lens. So their powers can be added directly. So refraction through a prism. Refraction through a prism. Mu equal to sin I1 by sin R1 or sin I2 by sin R2. I1 plus I2 equal to A plus D. A equal to R1 plus R2. That's why angle of the prism is known as refracting angle. And deviation produced is delta is equal to mu minus 1 into A. This is only for small angled prisms. And ID curve will be a parabolic shape. And the minimum deviation can be obtained from ID curve only. At the minimum deviation position, R1 equal to R2 is equal to R, not 1. R1 is equal to R2 is equal to R, and R1 equal to R2 is equal to A by 2. That R is equal to A by 2. And I is equal to, this is I. This is I. I is equal to, okay, I will write here. R1 is equal to R2 is equal to R is equal to A by 2, and I1 is equal to I2 implies I is equal to A plus D by 2, A plus D minimum by 2, D minimum by 2, so that these things will come. Okay, ignore them and you follow whatever I wrote. Next, dispersion of light. Dispersion of light. Theta is equal to delta V minus delta R, mu V minus mu R into A. Angular dispersion. Dispersive power, angular dispersion by mean deviation. Angular dispersion by mean deviation is the basic formula. These are all for small angled prism formulae. Next, this is like what you call dispersion without deviation. There shouldn't be any deviation. That means A into mu minus 1 combination must be 0. This is A into mu minus 1 plus, okay, minus sign, then fine, here I have to put a minus sign because total must be 0. Deviation produced by the first one plus deviation produced by the second one must be 0. So it should have a minus sign. Okay, so here I have to put plus sign so that automatically minus will come. Okay, that I don't want to change. It's okay. Here you can understand. Next, deviation without dispersion. Deviation without dispersion is angular dispersion should be 0. That means omega 1 plus omega 2 equal to 0. For this, omega 1 plus omega 2 equal to 0. This is deviation produced by one prism plus deviation produced by second prism equal to 0. Then it follows like this with a negative sign. And here is angular deviation of first prism plus angular deviation of second prism must be 0. This follows this one with a minus sign. Then you can enjoy these two. Next, optical instruments. The nearest distance up to which an object is seen clearly by the eye is called least distance of distinct vision, that is 25 centimeters. Myopia, short-sightedness. I have short sight means I can see closer objects or nearer objects. I can't see farther ones. For that, correcting lens is a concave lens. Correcting lens is a concave lens. Hypermetropia, that means I have long sight. That means I can see farther objects, not the nearer objects. So this is actually reading problem. So for them, convex lens is needed. These two are because of first one is elongation of eyeball, second one is contraction of eyeball, right? So press simple microscope. When object is placed between F and O, then virtual image on the same side of the lens will be formed. This is simple microscope. Magnification for simple microscope, M equal to D by F when object is at infinity, 1 plus D by F when object is at near point. And this is compound microscope. Actually simple microscope maximum magnification without aberrations, without errors, clear vision up to only 8 times of multiplication. So we use compound microscope in order to have better magnification. Compound microscope, M is equal to, if suppose n number of lenses are used in it, then total magnification is M1 into M2 into M3 so on up to n. Here two lenses are appearing for us, so M0 into ME. M0 is the objective magnification, the lens whichever facing object. ME is the eyepiece magnification, whichever towards the eye. And different formula of magnification, magnifying powers. M is equal to minus V0 by U0 into 1 plus D by FE, and when the image is formed at infinity for UE equal to FE, and image formed at infinite distance, then M is equal to minus V naught D by U naught into FE. And one more formula for infinite magnification, that means final image at infinity, then you can take L minus F naught minus FE into D by LD by F naught FE. So it's a better formula. This is approximated formula. This will give you only approximation. This will give you a better one. Length of microscope is V naught plus FE. That comes with the picture. Telescope. Astronomical telescope will give you inverted image. Astronomical telescope. Terrestrial telescope will give you erect image, and the magnification is beta by alpha, angle subtended by image by angle subtended by object. When final image is formed at near point, magnification M equal to minus F naught by FE, 1 plus FE by D. Length of telescope L is equal to F naught plus magnitude of UE. UE means object distance for eyepiece. And final image formed is infinity, then magnification M equal to minus F naught by FE, and length of the telescope is equal to F naught plus FE. These are all for astronomical telescope. Terrestrial telescope will come a different story. Just minus signs will be removed. Only length of the telescope will be improved by 4f, which is an erecting length or focal length. Remaining all aspects, these formulae, those formulae are same only. Terrestrial telescope will have magnifications positive. Astronomical telescope will have a negative magnification because of inverted image. Let us discuss wave optics now. This lesson structure is Huygens principle, refraction of a plane wave using Huygens principle, coherent and incoherent addition of waves, interference of light waves and Young's experiment, diffraction, polarization. Condition for applicability of geometric optics. Actually, this is the first point in few books only I noticed like this. Condition for applicability of geometrical optics is B square by L lambda very greater than 1. That means object size is greater, then we are going to see geometrical optics. Wave optics, that is nothing but ray optics. Wave optics we observe whenever size of the object is comparable or smaller to L lambda. Then only we are going to see wave optics. And lambda is equal to wavelength, refractive index is mu, that is sin I by sin r only. Cos I by cos r is nothing but width of incident beam by width of refracted beam, that is wavefront's width you can feel. Next, Doppler's effect in light is applicable as we discussed in the earlier, that is lambda dash minus lambda shift in wavelength is equal to velocity of source by light velocity into lambda. If the wavelength is increasing, that means the object is going away. If wavelength is decreasing, object is coming closer. Wavelength increasing, red shift, wavelength decreasing, blue shift. That is only Doppler's effect story. Radar. Radar is a system, radio detection and ranging, locating distant objects by means of reflected radio waves. And the same we are using, delta V equal to 2Vs. This is frequency, not V. This is frequency. Delta n you can take. Delta n is equal to 2n Vs by V, where n is the given frequency, shift in frequency, source velocity, light velocity. Like that you can take. That is frequency, nu, that is not V. Next. Relation between path difference and phase difference. Delta phi equal to 2 pi by lambda into delta x. Wave optics and waves have some part similarity, because here also superimposition, reflection are there, they are also there, that's why. And if light travels a path distance d, then mu d is the equivalent path. Mu d is equivalent path in vacuum. Relation between the time interval and the phase difference, delta phi equal to 2 pi by t into delta t. Interference of light. I maximum by I minimum is equal to A max by A min whole square. Amplitude square always will give you intensity. So A1 by A2 by A1 minus A2 whole square. Root I1 plus root I2 by root I1 minus root I2 whole square. Young's double slit experiment. The displacement of two light waves y1 is equal to A1 sin omega t, y2 equal to A2 sin omega t plus phi. A resultant amplitude A equal to root over A1 square plus A2 square plus 2 A1 A2 cos phi, whenever two waves superimposed at a phase phi with amplitudes A1 A2. and with amplitudes equal, then resultant amplitude is 2a cos phi by 2, and its a square proportional will be for the resultant intensity. This is resultant intensity formula I1 plus I2 plus 2 root I1 I2 cos phi, and I is equal to 4 I naught cos square phi by 2. For constructive interference, delta x is equal to d sin theta equal to d tan theta equal to d into distance of nth fringe by distance between source and screen, that is dy by d. Phase difference is 2n pi for brights 0, 1, 2, 3, 4 and so on. Next, position for nth maxima yn equal to n lambda d by d on the screen, and position for nth minima 2n minus 1 of lambda by 2. 2n minus 1 of lambda by 2 is the path difference. Obviously distance is 2n minus 1 of lambda by 2 into d by d. And for central maxima, I is equal to 4 I naught, which is the maximum intensity, and I naught is individual sources intensity. Fringe width beta is equal to lambda d by d, or people can memorize easily beta is equal to lambda L by d. So two different symbols will help you. L is source and screen distance, source and screen distance, and so this is L actually, and this will give you d distance. Better, instead of dd it will be better. And angular fringe width theta is equal to beta by d or lambda by d. This is angular fringe width, and theta equal to n beta by d for the nth fringe's angle. And whole medium is immersed in a other medium, maybe liquid or maybe water, like that. Then beta dash equal to beta by mu, as lambda dash equal to lambda by mu, theta dash equal to theta by mu. Intensity of light from a slit proportional to the area of slit width. So intensity proportional to slit width. Many people will have a confusion that either slit width is proportional to amplitude or intensity. Slit width proportional to intensity, right? Remember, if n1 fringes are visible in a field of view with wavelength lambda 1, n2 fringes with wavelength lambda 2, then n1 lambda 1 equal to n2 lambda 2, n1 fringe width 1 equal to n2 fringe width 2. Shifting of fringes, usually on putting a mica sheet or any glass slab on the path of one of the ray, then there will be a shift of so-called fringes. Entire pattern will shift either upwards or downwards, depends upon to which slit you are putting that mica sheet or any other medium. If a transparent plate of thickness t, refractive index mu is kept in the path of one of the wave, then fringe pattern shifts by a distance y equal to d by d into mu minus 1 into t, and beta by lambda into mu minus 1 into t is the shift in the pattern, and additional path difference is equal to mu minus 1 into t. On equating and using this and that, you are going to have number of fringes shifted is equal to mu minus 1 into t is equal to n lambda, where n is number of fringes shifted. So you can memorize like that, it will be better. What is that? Mu minus 1 into t is equal to n lambda. Missing wavelength, lambda is equal to d square by 2n minus 1 into d, and possible wavelength lambda equal to d square by 2dn. If the screen is placed parallel to the plane of the slits, then path difference equal to d sin theta. If the screen is placed perpendicular to the plane of the slits, then path difference is equal to d cos theta. Maximum number of possible maximum, of course this double slit experiment is applicable for even sound waves also. You can ask questions based on sound also. The same formula are going to act. Maximum number of possible maxima on screen, n is equal to n is less than or equal to d by lambda, and maximum number of maximas on the screen is 2n plus 1, that is equal to n, and fringe visibility or band visibility is equal to I max minus I min by I max plus I min. Linear width of central maxima is equal to 2d lambda by a or 2f lambda by a, and angular width of central maxima is 2 lambda by a. distance of the screen. Of course, f is focal length of the lens which is converging whenever light is coming from so far point for the secondary minima. Path difference is equal to a sin theta equal to n lambda, and for the, of course, if I give some heading it will be better, right? What is that? Well, just a minute. If I give some heading here it will be better. Yeah, it is there. Just this is Fraunhofer diffraction. Yes. Path difference a sin theta equal to n lambda, and nth minima linear distance is equal to n lambda d by a. Angular spread. See, if you know the derivation betterly for these things, then you can easily memorize. Otherwise, you will get confused. So learn and memorize with the help of the derivation, so that you won't get confused. Angular spread is equal to n lambda by a. Angular spread means distance between first minima and the first minima in between the region, that is making angle n lambda by a. And path difference is equal to a sin theta equal to n plus 1 of lambda by 2, where n equal to 1, 2, 3, 4. For secondary maximas, 2n plus 1 of lambda by 2. And linear distance of nth maxima is 2n plus 1 of lambda by 2 into d by a. And angular spread. If n interference bands are contained by the width of the central bright, then n beta equal to n into lambda d by d, 2 lambda d by a. These are all you need to study. That's it. Resolving power of telescope. Resolving limit is equal to delta theta equal to 1.22 lambda by d, and resolving power is equal to resolving limits reciprocal, that is 1 by delta theta equal to d by 1.22 lambda. R0 is radius of central bright, f is focal length of the lens. Resolving power of microscope. Minimum separation between 2 points in object plane, d minimum is equal to 1.22 lambda f by d, and d minimum is equal to 1.22 lambda by 2 tan beta. Those two formulae only in the first two lines. Polarization. Plane polarized light can be produced by the following methods: scattering, reflection, and refraction, double refraction. Dichroism. Brewster's law. Brewster's law is, in case of reflection, at one particular angle of incidence, the reflected ray is completely polarized, and that particular angle of incidence is known as polarizing angle. That polarizing angle's tangent, tan I, P, is equal to mu. And intensity of light transmitted through the polarized light is I is equal to, polarizer is I is equal to I naught by 2. Polarizers usually makes the intensity half, and our eye cannot detect the polarized light or non-polarized light. It feels that only intensity became half. That's it. Amplitude becomes 1 by root 2. Right? Malus law. Already polarized light is passed through another polarizer kept at an angle, then I is equal to I naught by 2 cos square theta, where I naught is before that unpolarized light. Next, let me explain in a little way. Suppose I naught is unpolarized light, enters into a polarizer, first polarizer, I can call it as P1, then just it is going to become I naught by 2 only. Here Malus law is not applicable. Malus law is applicable for, this is already polarized now. This is polarized. Now another polarizer is kept at an angle P2 to an angle theta, suppose. Then light comes out as, whatever this one is there, I can call it as I. Then I emerges out is equal to I cos square theta, or I emergent is equal to I naught by 2 cos square theta. This is, and you people are going to confuse with this. In Young's double slit experiment, resultant intensity is equal to 4 I naught cos square phi by 2. This is completely different. This is completely different. Okay, take care. Right? So I can tell you one hint to memorize it betterly. If the two polarizers are crossed, no lighting will come. So theta 90 degrees, 0 should come. If you put theta 90 degrees in the Young's double slit experiment intensity, that won't become 0. Because 90 by 2 will be 45. That won't become 0. So you won't get confused with this. Take care. Next. Oh, this is the end of the lesson. So keep on practicing the formulae. We'll discuss numerical problems. Bye.